incorporate, all the incorporated by reference from the DCD is going to say new reg 1966, and that's your key to say that incorporated by reference is the latest staff FSER related to the DCD. In fact, I remember you read an excerpt out of that FSER for DCD, and it referred to in the INC area back to Rev 6 of the DCD, Rev 7. Anyway, so you'll see that throughout how we do these FSERs, because it's not efficient for us to take that issue and go back every time we have a new rev of the FSR to go back to the staff and ask them to. I mean, they can do that if they have the time, but generally those issues were finalized back in previous revisions. So that's kind of the explanation.
I'm going to make a point on Chapter 7 in that back when we did the original DCD certification in Mike 2009? 10. GEH had made commitments relative to the configuration of the INC systems, and changes were proposed. They said they would make changes to the DCD to incorporate the agreements we had reached during the subcommittee and the final certification. And my biggest concern was, based on going from Rev 8 and seeing numerous references to Rev 10, did all those agreements translate into the later revisions? And as soon as I found my earlier emails and other agreement pieces of paper from 7 years ago, and then I actually walked them through. I didn't have Rev 8, which I now have.
Yeah, I sent that to you.
Yes, I got it.
Or I sent the version.
Yeah, he sent it to me, and I was able to step through the agreements to Rev 8. They were documented. Rev 9, Rev 10 were consistent. Whether I agreed with everything that we didn't quite catch back then is a different issue. We issued the certification, and I feel that we've got to agree with what we agreed with. So I'm satisfied right now, and I think I was the biggest vocal.
I think that was the one issue that came out of the subcommittee meeting was this issue, and we weren't going to raise it again because we felt like it's a DCD. But I'm glad you closed that loop for us because.
I just wonder, would it help, John, if they put something in the introduction to those chapters that still refer to
what bothers
7 that says these were closed based on that?
What bothers me?
I already did that.
Okay, that's good.
Chapter 1.
Because what bothers me is that 20 years from now, people might pick up this safety evaluation report and say, well, what was the real technical basis? And they'll go back to what it refers to, and could raise questions.
I thought it was a good point. It was a good point, and I thought it was confusing. To me, it wasn't confusing because I deal with it every day. But I could see someone from the public or anybody for the first time looking at this,
or other staff or the licensee once the plant is built to go back and look at least the staff safety evaluation of a particular issue. What was the fundamental traceability of that?
So as part of the FSCR of Chapter 1, we added a short paragraph to explain this very slide basically explained in a paragraph format that how these things were reviewed and finalized, these issues.
Thank you for doing that.
No, thanks for raising that issue, and I was able to, I think, add clarity for Chapter 1, so I appreciate it. So, just as last time for the subcommittee, we split this thing up into two areas, which was really the non-seismic information that were changes from the DCD or site-specific issues related to North Anna, and the seismic issues. And we'll, like I said, we'll go through some of the highlights of those. And start with meteorology. I don't think the meteorology was pretty straightforward. The ESP meteorology was finalized way back in 2006, and the only thing that was really changed in the later date was this update analysis to incorporate use of both ground level and mixed mode releases related to the stack for the rad waste building. There was some concern from the staff. They were originally using as it was a mixed mode release, and the staff questioned that based on the location, and they did a reanalysis and did the conservative route and did a ground level release, and that was all resolved. Still meets all the requirements, and you can see that all the regulatory requirements were satisfied, no additional open items. But that was really the only issue associated with meteorology over the last couple of years. And this really reiterates the flooding that Dominion talked about. It's the same information, 1 foot below the DCD site parameter on the maximum flood, and then the recent analysis on the local intense precipitation sheet flow found that there was a few doors that needed to have, thresholds so that water would not ingress into the doorways, and that's part of the FSAR.
But those aren't considered a departure from the DCD, the fact that they have to build up the doors? They weren't necessarily, it wasn't a departure in a sense, because the DCD is neutral to where, you have to do your individual site-specific flood analysis based on the site. It's not really a GCD issue, correct? The question was, is this a departure from the DCD related to the lip flow analysis? I'm sorry. You better get on the record with that. So, did our staff Joe, did you want to add anything to that? We have Joe Giacinto from the staff if he wants to add anything to that.
This is Gina Borg from Dominion. The answer is no, it's not a departure.
Joe, did you want to add anything?
Joe Giacinto, hydrologist. It's not a departure from the DCD. It's just a matter of flood protection, which we cover in Section 2410. So, although it's called out in Section 243, in Section 2410 it explains the type of flood protection. So, hydrologic engineering Section 24 is built specifically for these types of things, and it's not a matter of being in the DCD. It's a matter of review in the hydrology section.
Thank you. Thanks, Joe. Okay, again, we also did this accident analysis, and essentially the staff just confirmed what Dominion did using our own independent confirmation calculations and confirming these accident analysis associated with the industrial, transportation, and military facilities. Yes.
Ask a question, since I asked it of Dominion at the subcommittee meeting. So what was the analysis done to waive the accident with the delivery truck, the hydrogen delivery truck? How did you go about confirming their analysis?
Do we have, is it Ralph tomorrow? Yes, from the staff, he will come up.
Applicant has, and my name is Rao Tamara. The applicant has evaluated the frequency of the truck and also calculated based upon the historical accident rates. They determined the probability of the accident, and then they have shown the calculation that the probability is less than 10 to the power minus 7, which is acceptable to screen out that kind of accident. So we reviewed their calculations and we accepted the parameters and also the data that they have presented, and based upon that one we agreed the calculation is acceptable. And the probability is, since it is less than 10 to the power minus 6 with the actual realistic data, and it is within the guidelines of the acceptance criteria, therefore we accepted that one.
So as John pointed out, the probability, or the frequency is probably the right word here, for the truck accident is much higher than 10 to the minus 6. So
Actual accident might be, but the design basis accident is defined as the probability of the accident in conjunction with the release that would give a dose in excess of 10 CFR 50.34. That probability should be less than 10 to the power minus 6. So it is not just a mere accident which has a greater than 10 to the power minus 6 would not entitle that to be a designated as a design basis accident. So the definition is that both have to have the probability of 10 to the power minus 6. The accident in conjunction with the dose.
Let me just intuitively compare that to the other accident that was analyzed, which is a leak from the storage tanks. So you have a larger source. You have hydrogen in the delivery truck.
It's probably a smaller source in the truck compared to the storage tank, because you got a liquid hydrogen storage.
It is a 6,000 gallon tank, so the maximum tank can hold is 6,000. There are two tanks. So they have calculated the minimum distance that would not give more than 1 psi to the SSC, and that minimum distance is less than the actual distance. So that is the analysis performed for the tank. So the other analysis is you have a 13,000 gallon tanker truck delivering the hydrogen, which may, for our bounding case, we are assuming that is totally filled with 13,000 gallons. So this is done on a probabilistic basis because of the truck route. So that is the difference. Thank you.
How often do you're using the hydrogen regularly in operation? How often do you have to make deliveries? Do you know? How often would you expect the deliveries to be made? That might affect the probability, I would think.
Let me check on
the records are checked.
While they're checking, from my experience, you use hydrogen continuously during plant operation. At a PWR, you use some hydrogen continuously to keep the cover on the volume control tank. So you're losing a little bit of that. You're losing a little bit through the hydrogen seal oil system on the main generator. There's a little bleed, but your usage during power operation is limited to that. When the time where you really use a lot is when you shut down, purge the main generator, and have to refill it with hydrogen. So during any time you shut down and have to open up the main generator, you got to purge the whole thing. That's a reasonable volume of hydrogen in there. So makeup requirements are kind of limited by those evolutions.
Not to belabor this, but I just go back to the presentation. We've got two 6,000 gallon capacity tanks on site. So let's assume one of those leaks at some frequency or such. Obviously, they went through a calculation based on one of those tanks leaking, delayed ignition and then some kind of blast overpressure, conflagration overpressure. Now you have a single source that could be 13,000 gallons, twice as big as one of the tanks, in an accident. Why wouldn't you analyze that instead of a leaking tank? Because
The reason I asked my question is if the tanks are sitting there 24 hours a day, 65 days a year, the truck only comes in once every 10 years. I'm sure it comes more than that, but, there's a much lower...
handling the hydrogen when you have the delivery, it's kind of static tanks. Just, I'll let it go at this point.
Gina, were you going to make a comment?
Yes, this is Gina Borish from Dominion, and the analysis assumes 24 deliveries per year.
So it's twice a month.
Yes.
And for the record, he just reminded me that they're employing hydrogen water chemistry here, right? So that's an additional source of constant makeup.
When I asked Gina earlier what the primary use is, I asked if it was static cooling or if it was primary chemistry, and Gina answered it was primary chemistry. So this is the hydrogen feed to the red cooling system for suppression radiolysis. Yeah. And once every 2 weeks for delivery of gas, that's probably on a par with most plants. Got a hydrogen truck coming in every couple of weeks, got a nitrogen truck coming in about the same frequency. So that's not uncommon.
Okay, we'll move on to the next slide. Accident release. I have the little pretty picture. Dominion didn't have it. Again, we just really reiterate that the assumption from the condensate storage tank. Again, it's surrounded by a moat and also a drain line that's designed to capture all that leakage if the tank just instantaneously broke and spilled its contents. However, the evaluation is based on all the contents spilling into the yard and finding the closest, finding the fastest path to the water source, and all that analysis was done. Staff confirmed that and found it acceptable and meets all the requirements.
So Jim, I ask you, why is the condensate storage tank the objective of this analysis?
We have Steve Williams here that could, from the staff, that could answer that.
Steve Williams from the Radiation Protection Accident Consequence Branch. To give you some background on why the condensate storage tank was chosen as far as a release to the environment was in 11.2 and 2413 we do a combined analysis based on branch technical position 11.6. And that requires you to take the maximum concentration of any activity in an outside tank and then release that to the environment, even though it does have a dike and some protection around the dike as far as to prevent release. Then hydrology takes that and takes their values for dispersion and calculates an endpoint ECL concentration to ensure that they meet 10 CR20 requirements. Initially, when Dominion submitted their COLA, they had chosen 2 tanks that were inside of the Oxbow or inside of the plant. They weren't outside tanks, so it didn't meet the criteria for the condensate storage tank. And the reason, and for your question, you ask how does the condensate tank get activity in it? Well, it's used at points to recirculate from the spent fuel pool and clean up, and then just the normal cleanup from the condensate system as during operation is any contamination maybe from primary, secondary leak, and clean up the iodine or any particulates that they find.
Thank you, Steve. That takes care of my question to the applicant and also to the staff. Thank you.
Thanks, Steve. Okay, we talked about this hurricane missiles. It's really the effect was on the written structures, which was evaluated per the new reg guide. Really, the departure is related to a new reg guide that came out, reg guide 1.221, an update to that reg guide following the DCD final revision that was approved, and this reg guide came out, and so subsequent these COLA applicants, I believe Fermi even revised their COLA to include this new reg guide criteria, and so it was a departure. Dominion evaluated it, essentially affected the written structures, which is the non-seismic 1 structures. All the seismic 1 structures met all the criteria based on the wind speed and the hurricane.
So you're saying Fermi had the same departure?
I believe they did. I believe they had a similar departure. Yeah. Fermi didn't. Gina has additional information on Fermi on this issue.
You were busy with North Anna 3. This is Gina Borsch from Dominion. Fermi doesn't have a departure here.
The hurricanes aren't as big, then, I guess.
Probably time. We talked about that. This is rather strange, and I understand why Fermi doesn't have a departure here and why North Anna does.
All right, so now on to seismology. Essentially, in the seismology area, the mineral earthquake occurred, and there was a number of field studies. You can see that field reconnaissance to determine presence or absence of surface rupture displacement. There was a very extensive review of that, and our staff talked about that at the last meeting. It also came up from the public comment with fault A, which was previously discovered when Unit 1 and Unit 2 were being constructed, and that was evaluated in addition and showed that that fault A has been, for over 1 million years. It's been, it's an old structure that has no deformation associated with it when mineral earthquake occurred. Any questions? We do have our staff here if you have. Okay. And the vibratory ground motion, again, affected by the mineral earthquake. August 23rd, 2011, that affected so the local seismic evaluation was affected by that, along with the new Central Eastern United States seismic source characterization came out around the same time, so that was new. So they combined both some of the local information and that new seismic CEUS FSC to come up with a site-specific ground motion, which was, again, then that affected the seismic 1 structure evaluation. So that was the crux of the whole seismic closure plan and all that input into the final results of the seismic 1 structures. No questions? So the staff concluded that the GMRS, the local ground motion response vector, adequately represents the seismic hazard at North Anna 3 and meets the relevant regulatory requirements provided in 10 CFR Part 52, 10 CFR 123. And I think Dominion showed that the input for the seismic 1 structures. So associated with with the seismic structures, sections 3.7 and 3.8 of the staff SCR, reviewed the site-specific foundation input response, which is the FERS, which exceeds the DCD, which is part of the Certified Seismic Design Response Spectrum, CSDRS. So the departure and the exemption associated with the departure essentially was the definition of the site-specific SSE, which is the FERS plus the CSDRS. So they combined those two rather than just, in the case of like Fermi, it was the DCD was bounded the Fermi site-specific results. So they used just the CSDRS. So that's the difference. That's a departure. That was evaluated through the seismic closure plan. I think someone mentioned all these calculations, the specific calculations for each one of these structures and buildings. The staff completed 2 on-site audits. One was for the demand side, which was the input based on the FERS and the responses of the input to the structures, and then the second, which is the second audit, focused on all the calculations on the site-specific structures and the impact of that demand on those structures. And we spent a week at the GEH site and reviewed all these calculations. Had a team of our staff of 5 or 6 of our staff members, along with our consultant, participated in those audits. Now those were significant efforts associated with verifying these calculations, met our criteria and met all the Appendix B requirements, etc., along with all the REI responses and additional documents that are on the docket associated with our REI responses. And then this all culminated in the final FSAR Revision 9, and all this information that was in REI responses and COLA markups. That's how we reviewed these final sections 3.7.3.8 through the COLA markups, which were responses to the REIs, and then verified those in the final Rev 9 that they met what we accepted in the COLA markups. And you can see the staff did their own confirmatory analysis and seismic input motions and strain-compatible soil profiles, the SSI effects on the FWSC, which is that's the, what is it? For some reason I got it, FW, Firewater Service Complex. Yeah. Which is one of the 3 seismic 1 structures. And here's some of the results in Appendix 3G in the FSAR. It shows that the site-specific demand, except in a few cases, were met by the DCD. Our staff was very comfortable after reviewing all the reevaluation that the actual DCD was only exceeded in a few minor cases that Dominion mentioned, and we mentioned also here about the steel girder, weld size, anchor bolts associated with a couple of the structures. The thing that really struck me as a guy kind of following this as a non-seismic person, that when we come to the results and found out that nothing as far as the actual physical plant change, as far as the structure of the walls, the thicknesses, the base mats, the actual DCD structure was already a very robust design. And the staff just in some areas with all this analysis, and let me tell you, there was a lot of analysis, it came down to just some of these few items. So,
the exceedances are at relatively higher frequencies at 7 hertz and above, so you wouldn't expect that to have that much of an effect on the buildings. Yeah.
And I think I just mentioned this last slide, that standard design is adequate to meet the site-specific seismic demand is what the staff determined. And meets all the NRC regulations and guidance. The last thing we, part of this effort, we looked at just some of the effects of components, and two of them was the fuel racks inside the structures. We looked at those, and in some cases, we've determined that Dominion, we reviewed Dominion's results and determined that there was a couple places where they did some reinforcement for the fuel racks. You see that they found that for the spent fuel pool was adequate, and then there was in the buffer pool, I believe, yes, the anchor bolts. There were some anchor bolts in the buffer pool that were upgraded. And also, the staff reviewed the fuel inside the vessel associated with that seismic exceedance, and the concern there was that in the DCD, some of the stresses that were in the references to the DCD for the fuel design exceeded what was in the DCD. So even though the fuel design reports had a much higher margin as far as those design, conditions, the DCD had a specific number, and because there are exceedances, there's exceedances obviously where some of the fuel and therefore the staff looked at it, and they wanted to get a confirmation that at the end, that when you combine the loads, that you still don't exceed the actual mechanical design of the fuel as referenced in the DCD, and that was all confirmed, and none of those design constraints were exceeded. That was part of the staff review in Chapter 4. In conclusion, the staff completed a thorough review of North Anna 3 COLA, and as we mentioned, that focused on those areas that were site-specific. Much of the COLA, as you can see through our FSER, or SER, the Advanced Safety Evaluation, much of the information is incorporated by reference from the DCD or or directly from the Fermi evaluation. The published Phase 4 Advanced Final SE represents the staff final safety review findings for the North Anna 3 ESPWR. So I think that answers the little question came up about the FSER. The FSER is really just an administrative final product that would be prepared for the new regs. It's just part of a process that we go through. And that's all I have. Any questions?
Yeah, I had one. We have ample time here, so. The applicant and the staff, neither of you discussed the departures and exemption on the electric power system. We had some discussion about that at the subcommittee meeting. For the benefit of the other members, North Anna is proposing a change to the certified design connections to the switchyard. They're installing what's called an intermediate, they call it an intermediate switchyard, but basically it's 3 single-phase step-down transformers that go from 500 kV down to 230 kV with an isolation circuit breaker and motor-operated disconnects. And by doing that, it allows them to use the same design and voltage ratings for their unit auxiliary transformers and their reserve auxiliary transformers. In a certified design description, there's no... You just see lines going off to off-site power. So there's no particular voltage indications or anything. But this is something new, and it required a departure from the DCD because it does affect...
Even though those things weren't specified in the DCD?
Yeah, because